The sky tonight for the week beginning July 25th. Today we look at the sky for the week beginning Sunday, July 25th. With this edition of the sky tonight, the sky has changed somewhat since last week. In the morning, Mercury is in Cancer with the sun and lost in the solar glare before sunrise. The evening sky sees Venus remaining prominently placed with Mars setting earlier than last week. Scorpio, with red supergiant Antares, the heart of the Scorpion, is on the meridian at 9:20 p.m. Eastern Daylight Time, with Sagittarius due east and prominently placed by midnight. As they have been for the previous 3 weeks, Jupiter and Saturn are both well placed by 10:30 p.m. Eastern Daylight Time, with the waning gibbous moon in Pisces and rising at 11 p.m. on the evening of July 27th. The ethereal majesty of the summer Milky Way and the galactic center 25,000 light-years distant join Sagittarius on the meridian. As we did last week, the Great Summer Triangle, the hallmark of the summer sky in the Northern Hemisphere, is well placed midway up in the east for North America. Following the Milky Way northward from the galactic center, we find this asterism, consisting of brilliant blue-white Vega in Lyra, the harp, blue-white supergiant Deneb in Cygnus, and clear-white Altair in Aquila, the eagle. In this week's edition of The Sky Tonight, we'd like to highlight 3 favorites of the summer sky, 2 globular clusters and 1 galactic cluster. Globular clusters contain some of the oldest stars in the universe, some of the first stars formed after recombination. It is widely accepted that when the first stars formed in our universe approximately 13 billion years ago, they quickly came together to form globular clusters. These clusters then coalesced with others to form the first galaxies, a process that continues to this day, galaxies growing through mergers and evolving over time ever since. For this reason, we've long suspected that the oldest stars in the universe populate globular clusters. The study of these clusters is thus a means to determine the age of the universe, an evolving study still subject to some uncertainty. Recently, an international team of astronomers and cosmologists conducted a study of globular clusters to infer the age of the universe. All constituent stars of a globular cluster formed at the same time and from the same cloud of gas and dust, and thus constitute a single stellar population. This singular aspect of globular clusters provides a unique insight into stellar formation and evolution. Additionally, since many constituent stars date to the earliest epoch following recombination, careful analysis of their spectra and composition provides additional confirmation of the age of the universe of 13.8 billion years. Stars in these clusters, compared to the hot young stars in galactic clusters such as Messier 11, the Wild Duck Cluster, third of 3 objects of interest in this episode, are among the oldest stars in the universe. The first globular cluster we're going to discuss is Messier 4, 70 light-years wide and over 10 times the distance of Antares at 7,200 light-years, and immediately to its west is the globular star cluster Messier 4. In the Hubble Space Telescope, we see the diverse stellar population consisting of evolved red giant and horizontal branch stars, blue stragglers, and ancient population 2 stars. Although visible in a pair of binoculars as a soft, fuzzy globe, a telescope is required to reveal its true nature as an agglomeration of over 60,000 stars, all gravitationally bound together. The cluster is not as striking as other such clusters, as it is located behind the closer Rho-Ophiuchi complex, a region replete with gas and dust. The next object of interest is the globular star cluster Messier 22 in Sagittarius. Located at 10,600 light-years in the teapot of that constellation, also known as the Crackerjack cluster and similar to Messier 4, is Messier 22. Although this cluster is further away than M4, it's brighter as M4 is located, as previously stated, behind the Rho-Ophiuchi complex, a region thick with gas and dust. Appearing as a bright, fuzzy ball even in a pair of 10 by 50 binoculars, a 15 centimeter or 6-inch telescope resolves the cluster's brighter, evolved red giant stars with a hint that the center has fainter components. It's interesting to point out that these brighter stars, similar to the bright red star Arcturus in our skies at only 40 light years, appear close to the limit for such a telescope. This provides a lesson in stellar luminosities and distance scales. The larger the telescope, as is always the case, the more stars will be resolved, and this is true for all such clusters. The third and final object is Messier 11, the wild duck cluster, named as such since it appears as a flock of wild ducks. The cluster is easily observed in the constellation of Scutum in a pair of 10 by 50 binoculars and beautifully resolved in a 15 centimeter or 6-inch telescope. Unlike globular star clusters, the stars in a galactic cluster, such as M11 or the Pleiades, although all forming from the same source, as was the case with globular clusters, consist of young, luminous, A-class stars. Just to point out, interestingly though too, some galactic clusters, such as Messier 67 in Cancer, contain very old stars, and that's a topic for another discussion. All galactic clusters such as these provide good signposts and objects of study from which to model and confirm certain aspects of stellar evolution and how these stars evolve, some taking different evolutionary trajectories, others not, others evolving similarly, all coming from the same source. Uranus in Aries, requiring a telescope and flanking the third quarter moon to the east, rises at midnight tomorrow, July 31st. The moon, with Uranus, as mentioned requiring a telescope, is beautifully placed at 3 a.m. Eastern Daylight Time, with the Pleiades high in the east at 3 a.m. Note, with the exception of the Earth, Mercury, and Pluto, all planets of the solar system are visible during this time period.
This is Dr. Jim Daly of Astronomy for Change. May you come to love the stars too fondly to be fearful of the night. And remember, the Earth is a mote of dust floating in a sunbeam. That's reality. Everything else is just marketing. The great philosopher Plato famously said, "Astronomy compels the soul to look upward and leads us from this world to another." Astronomy for Change is a non-profit organization whose mission is to effect a positive change through astronomy and science education. It is our belief that by inspiring and empowering current and future generations to become interested and engaged in astronomy and science, this positive change will be realized. If you found this video helpful and educational, please like, subscribe, and share. Also, why not consider supporting us on Patreon? Head over to our homepage, astronomyforchange.org, click Support Us via PayPal or Patreon, and choose a membership level suitable for you. Every little bit helps us produce the great content and further our mission. Also, why not consider becoming a member? Choose the membership link here, click it, put your name and your first name and your email, and you'll be added to our list. You'll receive a comprehensive digest of all our videos and articles and all our great content. Joining and becoming a patron helps us grow and improve and more fully realize our mission. Thank you. This is Dr. Jim Daly for Astronomy for Change. Until the next video, please stay well and keep looking up.